Hello everyone. In this lecture, we shall discuss the Regula Falsi method or method of false position. If we recall our previous lecture where we have solved the algebraic or the transcendental equations by using this bisection method, right? And here we will use the Regula Falsi method to solve the equation f of x is equal to 0. The equation may be algebraic, basically nonlinear or transcendental, and it is too complicated that the usual method of solution is not possible. So now likewise, as in the earlier case, we have to use the intermediate value property, right? That f of a into f of b negative, then only the root of fx lies in between a and b, and we have to find it as the initial approximation. Suppose my x0 is my a and x1 is my b, so these are my initial approximations. So in some problems we need two approximations initially. In some method we need only one approximation. Okay, so now we'll discuss the necessary formula for the Regula Falsi method. So before the detailed discussion of the formula, let me to introduce myself. Professor Susanta Kumar Paikray, currently working as a professor in the Department of Mathematics, Veer Surendra University of Technology, Burla, Sambalpur, Odisha, India. Okay, so without much delay, let us now discuss the necessary formula for your Regula Falsi method. So the necessary formula is xn plus 1 is equal to xn minus xn minus 1 divided by fxn minus fxn minus 1 into fxn. Okay, fxn. So this is the necessary formula for your Regula Falsi method, right? And this formula is subjected to the condition of the intermediate value property. That means, and here if I write xn, it is equal to xn minus xn minus 1, and if in short I write, suppose it is my fn, and it is suppose my fn minus 1, and into it is my fn. In short I write f of xn is fn, right? And here the condition is that fn minus fn into fn minus n into fn, right, must be less than 0. This condition, right, this is such that this condition must be there in every step. This condition must be there. Okay, and here n is equal to 1 2 3 so on, because x0 we get it, x1 we get it. Now if you put n is equal to 1, for n is equal to 1 we find x2 is equal to, for n is equal to 2 we find x3 is equal to. So these are my subsequent approximation. I go on continue till I get my xn. Okay, xn minus 1, and I get xn, right? And the thing is that this should be close enough. Suppose my xn minus 1 is, suppose I say 5.234679, and suppose it is my 5.234826. Now it is correct up to these 3 decimal places. You see, it coincides up to these 3 decimal places. Okay, means these are very close here. So we'll stop it here. This is up to 3 decimal places. Okay, so this is the idea. So now let me to discuss the details of this formula, right? So this is the idea to continue. Now let me to discuss the details of the formula. So if I re-simplify this formula, okay, just have a little bit of calculation. This will give me here xn into fn minus xn into fn minus 1, then you have this xn into your minus xn into fn, it is minus plus plus xn minus 1 into fn divided by fn minus fn minus 1. If I simplify, I just simplify it. So now here, so consequently you see xn fn is cancelled. So what we are getting? We are getting xn minus 1 fn minus here xn fn minus 1 divided by fn minus fn minus 1, right? So this is my xn plus 1. So we simplified it to get this. Now if we want to further simplify, if I put now, suppose my xn minus 1 is my a, xn minus 1 is my a, and xn is my b, accordingly fn minus 1 is my fa, and accordingly fn is my f of xn is my f of b. Then this formula will be xn plus 1 will be is equal to a into fb minus b into fa by b minus a. So this is my necessary formula, such that this restriction has to be there in each step. This fa into fb is negative in each step. Okay, so this is the restriction here. So my n is my 1 2 3 so on. So this is my necessary formula. Okay, this is my necessary formula with this is the restriction in each step. Okay, so either you may use this or you may use this. So whatever easy for you, you can recall it. Okay, so now on this basis, if I ask you, so now in view of this formula, if I want to put, suppose my n is equal to 1, then it will give me x2 is equal to, here n is my 1, so it is x0 f1 minus x1 f0 by f1 minus f0. Means here x0 and x1 known here, okay, x0, and so we get it x2. Then we find, so then here we have to find fx2. What is fx2? It is positive or negative, we have to check. Okay, whether it is negative or positive, we have to check it. Then we have to find if fx1 into fx2 is negative, then only here next interval will be I1 will be here x1 x2. Then you find here x3. Here x3 will be x2 f1 minus x1 f2. So I mean to say here n is equal to 2 here. Okay, so my x3 will be x1 f2 minus x2 f1 divided by f2 minus f1, only when this is negative, right? Accordingly we find x3, and we go on continue. So this method is behave like the bisection method, but the strategy is different. Okay, so here it behaves like bisection method. Okay, bisection method. However, the strategy is different. Okay. Also, this is a bracketing method, right? Also, this is a bracketing method because in each step and this method will shearly converge to a root. The convergence may be slow, right? The convergence may be slow, right? But it will shearly converge to a answer. Okay, so if I solve a problem, then your idea will clear. So before that, so you may have this is the formula or this is the formula. As per your convenience, you may use. Okay, let me to make you understand this diagrammatically. or geometrically. So as you have seen, this method behaves like the bisection method. So in each step we just check the intermediate value property. That's why this method must converge to a root. Okay. However, the convergence is slow. In particular, right? In particular, this method converges linearly. Okay, means at what speed it will converge. The rate of convergence, at what speed it will converge to the final answer, final root. The rate of convergence of Regula Falsi method is 1. That's why it is called linear. Okay. Now we will just derive the formula and geometrically interpret the basis of this method. So now coming to the geometrical interpretation, consider f of x is equal to 0, right? Let fa is negative and fb is positive. Suppose we have the graph is like this. Suppose the graph is like this. This is my x-axis and this is my y-axis. And suppose this is my curve. This is my curve. So at the point A, this is my point A and this is my FA. And the coordinate of this point is AFA. Let this is my capital A here. And this is my point B here. This is my point B here. Now this coordinate is, suppose this is my point capital B with B and the functional value is my FB here. So this is my f of B here. So now this curve crosses x-axis. At a point you say this point is my P and the coordinate is my alpha here, alpha 0. So alpha is my root here. Alpha is my root here. We want to find the approximation close to alpha. So we have to choose an initial approximation in between A and B. So we draw a chord here. Suppose we draw a chord A and B, we join it. Okay, we join it. Suppose it crosses the curve, it crosses x-axis at my P dash. I suppose call this point P dash is suppose my x1 0 here. So x1. So now x1, this point is my x1 here. This point is my alpha here, right? So alpha, so this point x1 is an approximation to my alpha, right? So now coming to the equation of, this is a chord here. So coming to this is a straight line. So equation of the line here we find. So let this point be my x1 y1 and this point be my x2 y2. Okay. So what is my equation of line? Equation of line passing through 2 points. Equation of AB here. Okay. AB here. So equation of A x1 y1 B x2 y2. Right. So this equation of this line AB, this equation of this line AB is what? Y minus y1 is y2 minus y1 by x2 minus x1 into x minus x1, right? So now if I divide it, so that means y minus y1 divided by x minus x1 is y2 minus y1 by x2 minus x1. So this equation of AB with my A coordinate is this B coordinate. So this is the equation of the line. I write it in this form. Now substituting A and B here, what we are getting? Now this implies my y minus FA. So this is my FA divided by x minus A is equal to my y2 is my FB minus FA divided by B minus A, right? Next, so now you see x1 is my first approximation. Now in view of x1 at P1 point, the y coordinate is 0, right? At P1 y is equal to 0. It crosses x-axis, right? So what will happen? Substituting y is equal to 0 here, this will give me minus FA by x minus A is FB minus FA by B minus A So if I simplify it, so you cross multiply it, it is x minus a into fb minus fa. Okay, and you cross multiply it. This is equal to minus of b minus a into f of a. If you simplify it, here ax into fb minus fa minus afb plus afa. In the right hand side it is minus bfa plus afa. So if I simplify it here, ax into fb minus fa is here afb minus bfa. Here this and this cancelled. Okay, so it is simplified to give this now. So what implies my here x is afb minus bfa, okay, divided by fb minus fa, right? So this is my formula. So I may write it xn plus 1 here. I replace x by xn plus 1, okay, and this where my n is my 1 2 so on, and the restriction is that such that fa into fb is negative. This restriction is there, this restriction is always there. Okay, so this is the necessary formula here, right? So now for this, if I go on approximating, so now I have so that means here my alpha is a root of this equation. Now x1 is an approximation, so now I draw a perpendicular here, right? Let this point is my capital C, CFC now. Okay, now I draw a chord here again. I draw a chord here joining these 2 points. Okay, joining these 2 points I have a chord here. So now this point is my x2. So x2 is another approximation which may be close to your original root alpha, and we can go on continue like this. Okay, so we can go on continue like this, means we have my for my n is equal to 1, I have my x2, right? X2, then I go on continue, and my xn plus 1 is equal to xn minus 1 fn minus xn fn minus 1 divided by fn minus 1. So this is what we have discussed. So this is the geometrical background and the derivation of the formula for this Regula Falsi method. So so we may use this formula, right, or we may use this formula. So while I solve a problem, then your idea will clear. So likewise for your, if in this formula if I put n is equal to 1, I get x2. In this formula if I put n is equal to 2, I get x3. In general, this is my formula. Now some remark on this Regula Falsi method. So now coming to most important remarks. If we take the initial approximations are close enough, are very close to each other, then we get the answer very quickly, right? Quickly. If the first approximation x1 lies on right or left side of the curve, then all the subsequent approximation x2, x3, x and so on, means if x1 is lies here in this left side, then x2 also lies, x3 also lies, and so on, xn plus 1 also lie on the same side of this curve. Alright, same side of the curve. The bisection method or Regula Falsi, likewise bisection method, this method is also called a bracketing method. As in each step we check fa into fb is negative and get an initial interval enclosed by the brackets. Okay, thus this method is surely converge, right? As we are checking that fa into fb is negative, so this method will surely converge. The method of false position or this Regula Falsi method is slow, but and the convergence is of first order, linearly converge. Okay, but it will converge surely. The convergence is guaranteed here. Most often it is found superior to bisection method, right? And most importantly, the method is named as method of false position. Method of false position. Okay, why? Now because it is also otherwise called the trial and error or guess and check technique, because here we use the false or test values, right, of the variable. At the beginning we use the false or test values subject to the condition fa into fb is negative, then the variables are adjusted, okay, according to the desired outcome, right? That's why this method is known as the false position method. So let us discuss some important examples, then your idea will clear. So now let us solve one problem. Use Regula Falsi method to find a real root of this. This is my fx, correct to 3 decimal places, okay? Also the same problem we have solved by bisection method in our lecture 1. Now coming to the solution, let my f of x is equal to x cube minus 2x minus 5, right? So in view of finding the initial approximation, what is f of 0? It is 0 cube minus 2 into 0 minus 5 is minus 5 is negative. Then what is my f of 1? F of 1 we find minus 6 here, and it is here negative. What is f of 2 here? F of 2 we find it is minus 1, it is also negative. And f of 3 we find it is 3 cube minus 2 into 3 minus 5, and it is here 16, it is positive here. So you see here immediate this 2, f of 2 is negative, f of 2 is positive, so therefore f of 2 into f of 3 is negative. So this implies root lies in between 2 and 3, okay, or in the interval or in 2 3, the root lies in this interval, okay. So now we find the necessary formula. Now one more thing, if we squeeze this interval, okay, if we squeeze the intervals, suppose I find what is f of 2.1. if I want to find f of 2.1, I want to find, so this is 2.1 whole cube minus 2 into 2.1 minus 5, and it is my plus 0.061, it is also positive, you see. So rather than taking 3 here, okay, rather than taking this 3 here, if I take this 2 and 2.1, then this 2 and 2.1 are very close, so I may achieve the answer quickly, right? So if we move like this is fine, but to get the answer quickly, as f of 2 into f of 2.1 is negative, right? So root lies between 2 and 2.1 or in the interval to 2.1, okay. You see this interval is, the endpoints are close enough, so we get the result quickly, right? Now the necessary formula, okay, we have our necessary formula is this, right? So now coming to the first step, fast approximation, okay, fast approximation. In fast approximation, what is my a is my 2, right? And what is my b is my 2.1. What is my f of a? F of 2 we got it minus 1. And what is f of b? F of b is f of 2.1, we just get it 0.061. So for n is equal to 1 here, what is the formula here? x2 is equal to, right, here x2 is equal to here AFB minus BFA by FB minus FA. If you substitute all this thing, it will 2 into 0.061 minus 2.1 into minus 1 divided by 0.061 minus 1. So if you simplify, it is 2.0942. So this is your x2. Then we go to next step. So before going to the next step, we just find, so this implies my f of x2, right, is equal to f of 0.0942. I must check it, okay. So this is 0.0942 whole cube minus 2 into this is my 2.09, 2 into here 2.0942 minus 5. If you simplify it, it will be here minus 0.00392. You see it is your negative here. So likewise the bisection method, we have to search the immediate positive. So it is my negative here. So the immediate positive here is, we have to find. You see this is the immediate positive here. Okay, this is the immediate. So we take 2.1 and my this clearly, right? Clearly f of 2.1, right? 2 point, or I may take it this 2 point, this is 2.09, sorry, f of 2.0942 into f of 2.1 is negative. Okay, so therefore, so this implies root lies in 2.090942 comma 2.1. in this interval the root lies. So in the next step I must take this value is my a, this value is my b, and accordingly I have to proceed. Now coming to my second approximation. In second approximation, my let a is equal to 2.0942 and my b is equal to 2.1. So that means my f of a is my minus 0.00392 and my f of b is my 0.061. Okay, in each step we adjust what is a and what is b. Okay, if we write this is a and this is b also, no issue, we can reverse it also, no issue. So now, so this implies for n is equal to 2, my x3 will be equal to the same formula, afb minus bfa by fb minus fa. The only thing we have to adjust a and b in each step, right? So if we simplify it, it will be 2.0942 into 0.061 minus 2.1 into minus 0.00392, this divided by fb 0.061 minus of 0.00392. If I simplify it, it is my 2.09455. You see here, so this is my x3 here and this is my x2 here. You see this x3 and x2 are very close in fact and up to 3-digit accuracy, right? 094 and 094 are same here. Okay, so in this 2 step we are getting the answer. It is quite closer to each other, right? So hence comparing x2 and x3, we observe that the values are same up to the place of third decimal, is not it? You see, after the decimal point 3 places are same, and therefore the approximate root up to 3 decimal places is 2.094. So this is my answer. Okay, so let us solve one more transcendental equation. If you can recall, we have solved the same problem by bisection method. Okay, in our previous lecture also the same example 1 we have solved it, but we got the answer after 5 iterations. Okay, but here in 2 iterations we got it, and the reason here is we just close this interval 2 and 2.1, right? If you take this interval, then more number of iterations is needed. So the thing is that we try to make the interval close. Okay, then we will get the answer quickly. So coming to one more example for solving the transcendental equation. Now coming to the next example 2, you are given the function fx is this. Okay, and we use the false position method by we adopt 3 steps as per the given instructions. Now coming to the solution, you can recall the same thing also we have solved in lecture 1 by using bisection method. So let my fx is equal to x log x to base 10 minus 1.2. Okay, what is my f of 1? So this implies my f of 1 is minus 1.2. Use the calculator. Okay, f of 1. What is f of 2 here? Minus 0.6. It is also negative. It is negative. So what is f of 3 here? F of 3 is my 0.23. It is positive. Now you see these two consecutive. This is negative and this is positive. So root lies between 2 and 3. Okay, as f of 2 into f of 3 is negative, so root lies in the open interval 2 and 3, right? 2 and 3. Now to get the result quickly, okay, to get the result quickly, we see that at 3 this is close to 0, at 2 it is close to 0.6, at 3 it is close to this. So let us take some points closer to here 3. So if I find, moreover, what is my f of 2.7, right? F of 2.7 will be 2.7 log base 10, 2.7 minus 1.2, it is minus 0.0353. And what is my f of 2.8? It is my 2.8 log 2.8 to base 10 minus 1.2, it is my plus 0.052. You see these values are close enough, right? You see here this value is negative and this value is positive. So if I choose 2.7 and 2.8 instead of this, if I choose this, then I get the answer quickly, as f of 2.7 into f of 2.8 is negative. So root of fx equal to 0 lies in the open interval 2.7 and 2.8. okay, if I choose 2 3 then also okay, but many steps we have to adopt. Okay, but here a little number of steps will give our answer. So now our necessary formula is this. This is my x0, this is my x1, right? I have to find x2 onwards. So now coming to my fast iteration. So let my x0 or a is equal to 2.7, b is equal to 2.8, and my fa, as we get here, fa is minus 0.0353, minus 0.0353, and my fv is 0.052. okay, so for here n is equal to 1, your x2 will be here, you substitute, x2 will be that same afb minus bfa by b minus a. If you substitute all these things, it will give you 2.7 into 0.052 minus 2.8 into minus 2.8 into minus 0.0353, okay, divided by b minus a. Here 2.8 minus 2.7. If you simplify using your calculator, you will get it 2.7404. okay, now what will happen at x2? Now at x2, what is f of x2 here? So f of x2 is f of 2.7404, right? And if you simplify it, you will get it minus 0.00021. It is here negative here. Since this is negative, we search the immediate positive here. The immediate positive, so this is negative here. The immediate positive is here. The immediate positive is here. Okay, this is my immediate positive, right? So my b is 2.8. So the root lies here between 2.8 and 2.7404. okay, now thus I will write here as f of 2.7404 into f of 2.8 is negative. So root lies in 2.7404 comma 2.8. okay, so in my second iteration, let this is my a and this is my b. okay, let my a is equal to 2.7404 and b is equal to 2. In each step we have to adjust a and b according as fa into fb is negative. So what is my f of a? F of a is my minus 0.00021 and my f of b is my 0.052, as we have seen here. F of b is here. Okay, so now my what is my x3? So now x3 is equal to here afb minus bfa, afb minus bfa by b minus a. If I substitute all this thing, okay, it will give you 2.7404 into 0.052 plus 2.8 into 0.00021 divided by b minus a, 2.8. Just a correction in the formula. It is fb minus fa. It is fb minus fa. Okay, so this will be 0.052 plus it is minus of minus means 0.00021. Accordingly here also please rectify it. It is fb minus fa. Okay, it is fb minus fa. So it is here 0.052 plus 0.0353, and accordingly here also this formula is fb minus fa. Okay, fb minus fa. Likewise here also here we have done it fb minus fa, right? Here we have done it fb minus fa. Okay, so now if you simplify it, you will get it 2.7406. Now what is my f of? So this implies my f of x3 is my f of 2.7406. If I simplify it, minus 0.00004, which is again my negative. Since this is my negative, I have to immediately search the next positive. I have to search. This is my negative. Okay, so the immediate positive, where is the immediate positive here? This is negative, this is not considered here. Now I see the immediate positive here. The immediate positive is here. Okay, here it is immediate positive is here. So I consider this 2, right? F of 2.8. Okay, and my this as f of 2.7406 into f of 2.8 is negative. So root lies in 2.7406 comma 2.8, right? So in my final step, in my third iteration, right, let my here a is equal to 2.7406, b is equal to my 2.8. Accordingly my f of a is my minus 0.00004 and my f of b is my 0.052. So my here x4 will be afb minus bfa by fb minus fa. If I simplify it, this will give me 2.740646. Okay, so if you compare these two consecutive, it is 2.7406 and here it is 2.7406. Okay, so up to 4 decimal places here, our answer is correct. So here you see, if we compare these two, it is the up to 4 decimal places it is matched. So comparing x3 and x4, right, what we see, the same value up to 4 decimal places. Hence the required approximate root is this 2 point this. Okay, now coming to the concluding remark of this lecture, in your Regula Falsi method or method of false position method, in each step we have to check fa into fb is negative, right? Since we are checking that fa into fb is negative, so based on the intermediate value property, this method will surely converge, right? However, the convergence is slow, it is linear. Okay, moreover, the convergence is better than the second method, and the importance is that if you squeeze the interval, the initial approximation, if you choose close enough, right, as we have taken 2.7 and 2.8 instead of 2 and 3, then we get the result quickly, right? So try to choose the initial approximation, initial interval is very close, then you will get the desired accuracy. So now my request to all of you is that if you find this lecture is interesting and helpful to you, so just subscribe to this channel and also like this channel, which will boost my motivation to upload the subsequent videos for your benefits. So with this, we should close this lecture here. Thank you all. Have a nice day. Once again, thank you all.